Today we're gonna talk about covariance and correlations and what's the relation between them, and we're gonna talk about this. And this is like from my own notes. I got so many inspiration for these presentations. So one of them is from Ben Lambert presentation, but I made it for my own. Remember, first, let's talk about covariance. So what is covariance? And this is somehow like some people confuse between covariance and what is then with correlation. What's the difference between both of them? Okay, so let's see. Let's say we have value y and x. We can say, like, for example, this is the relation. Y is the status of the school. For example, it's a private school status, and this is, for example, the achievement of the student on this school. And if we take like the example like this in the implementations, if there are like the amount of the relations between x, for example, the status of the school or the private or the tuition fee, okay, maybe tuition fee of the private school, okay, if the tuition is higher, so usually the achievement of the school is also getting higher, and this is why we call it as if the x going bigger, so the y also getting bigger. So this is like there is positive relationship on it, so that's why I give the sign is like someone smiling. And the other one is the negative relationship. So for example, if the amount of x is going up like this, by x going up here, the y is going down, for example, like that. And all of them, yeah, I forgot, is like random variable. So what is actually the formula of covariance itself? So I would say this is like by x going bigger, the y is going smaller. How to put it in the math then? So the formula here is the expectation value, or like this, the expectation of x minus with mu x and y with mu y. What is mu? What is mu? Here, mu actually is the amount of x, like the mean of x, and this is the mean of y. Let's take the example. So here is like if the amount of x is bigger than the x mean, or let's say here it's x is bigger than the mu x, okay, and let's say we want to see like how to put it as the very basic mathematical relationship, where like plus with plus it will be plus, minus with plus it will be minus. Okay, so if x somehow bigger than its mean, then it will give us like plus, while also if y, let's say it's here, or let's make it like easier, like if y it's bigger than mu y, and we put it here, so it's like plus. So what's then? It will give us the relation plus and plus become plus. And what if x is smaller than mu x minus, and but then the y is also smaller than its mu, so it's like minus, then the relation become positive. Okay, and then what if the value so on, like x bigger than mu x, which is plus, but then the y is like this one going here, which minus, it's become minus, and x, for example, smaller than its means, it's minus, and then the y is like bigger than its mean, so its mean it's minus. And since every of these variable here, like x and y, they have a unit, so it makes like everything here, like x have the unit, y they have unit, so it means covariance also has a unit. And because it has a unit, we also want to see, like in the terms of role, instead of telling it as covariance, we want to put it as correlations, because correlations component is made from the covariance. Okay, and then, so what's the formula of correlations? We already put here the correlations, but let's see. Correlation here, maybe here it will be easier. Okay. 3 is we want to talk about correlations. So the correlation formula, basically it's more into like covariance x and y divided by the variance of x multiplied by variance of y. So for example, if the amount of x is by plus 1 and y, for example, it's minus 1000, then, you know, like no matter what the relation will be, plus 1 and minus 1000, the value will be still like minus. And we don't want to like whatever the value will be, we want to see like if it's like plus and minus and divided by the variance, the value of the x and y will never exceed the value of variance, because x will never exceed like how to call it, will always smaller than the variance of x, and it always happens this way. So that's why if we put, like for example here, the covariance x and y divided by var x and var y, and then we call it as row, because usually correlation using row, it will be always minus 1 row until 1. So this is the value of the correlations. So if the correlation is minus 1, it means x and y, it's really the opposite side, or really like when x going up, here when x going up, y will going down, and 1 is like when x going up, y also going up, and 0 it means there is no relations or at all. Okay, so this is how it's look like in the way of the explanations, how it works in STATA. We will go to the next video. Thank you for following. See you in the next video. We have from the default of STATA, because STATA actually also bring the data. We're gonna use the data from the connection between the salary range with the tenure. So let's see, describe. There is the age, the wage, the union, and so on. And if we click the browser, there is like information about the code, the age, the race, marriage, and then like how long they are working, the tenure, and the salary per hour. So we get all this data, and we want to know like how it works. So first, let's see like how the scatter plot look like. So first, let's say like we want to make some graph with scatter, wage, the connection between wage and the tenure, and if they are joining with the union, because this is what we also want to know, whether is there any difference when they are joining with the union or not. And then sort, it means we sort based on the variable of independent, which is here is the tenure. And then the color, let's say like if they are not joining, the color is red gonna be, and then let's say the size of the scatter that we want is small, and then close parenthesis, and then another one, scatter wedge as the dependent tenure if union is equal with 1, and then sort mcolor to blue, and the msize is small. Enter. So we get the data like this. As you could see, like if there is the covariance analysis, whether when the tenure or the person working for such a period of time, then actually their salary going increase or not. And as we can see here, it looks like there is a positive correlation. Even it doesn't look like also, because as you could see, the color red here by the times, actually they going lower, and the blue by the time it looks stable. Okay, let's see the deeper analysis of it. We can use the ANOVA analysis for the covariance analysis. So put like we want to compare wage and the tenure. We put the first word C in the front because it is continuous data, and then we put also the union. Bam. So we get the data here, like the F value from the ANOVA. The R square is 0.08545, which means like it's only 8% that this correlation actually explain what's the real things that happening. And then also the model, we get the data is like probability with lower than 0.0, so it's like if there will be hypothesis, then its hypothesis is accepted. Okay, let's see. We can also use the command regress and put the dependent variable in the front, wage, and then tenure, and then e-union, ye, because it's like independent, and we know like this is binary data of the union. So let's see, and enter. We got the data which is similar, basically like you got the information whether like the F value is the same with the previous one here. Okay, and from here we can also see how it looks like in terms of the model, whether the hypothesis is accepted or not. Okay, so from both ANOVA and regression we can see the covariance analysis. And now let's see, like if we want to predict whether if someone join with the union and not, whether actually there will be like different in the salary. So we use the word predict, and then let's see, like here we make a new variable, predict wage, and then let's say if they don't join, so predicted wage not join union, we call it like if union is equal with 0, and then okay, we make 1 and predicted wage join union if union equal 1. Okay, so we already make like 2 new variable as a predicting. So let's see how it looks like in the scatter plot. So we make like two-way scatter plot again. First is like the scatter plot, which using wage and tenure correlations. If union is equal with 0, and then sort based on the dependent variable, and then the color will be red because they don't join with the union. The size will be small, don't forget your parentheses. And then the second one, we can actually just copy this and then paste with some modification with the union 1. Let's say the color here will be blue. And then another one is like we want to put this predicted variable, so we use the, instead of scatter, we use line, and then predicted which not join union. Okay, and then we put the word, the independent variable tenure, and then we also want to sort it out. Line color, we want it to be red, and then the pattern, we want it to be solid. Okay, and then we can just copy with some modification here. Okay, so predicted wage by join union, the tenure, so the color, let's say it's gonna be blue, and hopefully it works. Predicted wage, join union, predicted wage, predict the, I make like some typo here, where I supposed to not putting the word D. I'm sorry for my mistake. Red, lpattern, and predict. Yeah, because as you could see here, I'm using predicted which join union, and then the one that I make in the first one is like predicted with join union. It's just typo. Okay, let's enter. Boom. So we could see like actually this line with the predicted, it's giving much better comparison. So if someone join with the union, basically the covariance, it's much higher than someone who are not joining union. So as the time when someone join union, when they have like higher tenure, the level of their salary also much higher in comparison with someone who are not joining union. So I hope it's helped. Thanks for stopping by in my channel, and if you see it's useful, do not please consider to subscribe. Thank you guys. Hey, my name is Dimas. I'm from notafraid.id Institute. I'm a final year PhD student in Krakow University of Economics in Poland. I have published a couple of articles. At the same time, I'm also like a senior manager in one of the largest P2P platform startup in the world. And within the course, we will learn a lot of things connected with econometrics, because I understand that studying econometrics can be very challenging, because we try to find what's the theory and how it applies in the real world, and not everything's in the theory actually have the application in the real world. That's why during the course we will try to find what can be. So we will go through all the checklists that we have in the STATA course, and then after that we will see how it will be implemented in the code, and perhaps we will find everything's in the applicable way. So if you think everything's it's gonna be useful for you, please also consider to subscribe this channel, and also see you in the next course. And if you have a couple of questions, feel free to ask in the comment section. Okay, so see you in the next course, and happy learning. Bye bye.